I'm going to answer questions from Airborne Weather Radar chapter in Keith Williams' Radio Navigation book. Previously, I have answered first 20 questions. In this video lecture, I'm going to answer next 10 questions, namely question 21 to question 30. So let's start. Question 21. Airborne weather radar are generally based on what? So remember, all airborne weather radars operate on the principle of primary radar. Primary radar. Now, what is primary radar? In a primary radar, let's say this is your aircraft. Okay. Primary radar, you are going to transmit a radio energy in the direction of your target. This transmission happens at a particular frequency. This radio energy will get reflected from this target and go back to the receiver, that is your aircraft. Okay, and the reflected frequency will be the same. So the transmitted frequency is equal to the reception frequency. That is the essence of primary radar. Now in case of secondary radar, in this case of secondary radar, what happens? The principle of operation is that the transmitted frequency, that is your interrogation frequency, is different from transponded frequency. So let's say there is a ground station. And you have aircraft in the air. So this ground station will send an interrogation signal. It will send an interrogation signal to this aircraft. This interrogation frequency will be at 1030 megahertz. Aircraft will receive this frequency and send another signal towards the ground, which will be a response signal. The answer to this interrogation signal, the answer or the reply or the response to this interrogation signal will be called transponded signal. And it will send the signal to the ground station, back to the ground station at a different frequency, which is 1090 megahertz. So as you can see, the transmitter frequency is different from receiver frequency, 1030, 1090. So this is the essence of secondary radar. So your airborne weather radar is an example of primary radar. It operates on the frequency of 9.375 gigahertz throughout. Okay, so there is no frequency change, so no concept or no idea of secondary radar. It works on primary radar. So correct answer is primary radar in super high frequency band, which is 9.375 gigahertz. Question 22. In the mapping mode, the airborne weather radar utilizes what? So remember, I have explained this multiple times. In the mapping mode, first 70 nautical miles and the next 70 nautical miles. So in the first 70 nautical miles, the mapping mode happens in fan shape with the help of fan shaped beam or cosecant beam. In the next 70 nautical miles, we make use of pencil or conical shaped beam. So fan shaped beam is effective up to 150 miles? No. It is effective up to only 70 miles. Fan beam effective up to maximum 50 to 60 miles? Yes. Pencil beam effective from 0 to 150? Wrong. It is 70 to 150. So delta pencil beam effective to a range of 60? Wrong. It is effective from 70 to 150. Not from 0 to 60. From 70 to 150. Next, question 23. In airborne weather radar, the main factors that decide whether or not a cloud will be detected are size of the water droplets and the wavelength of the frequency used. Remember, the wavelength that we use in case of airborne weather radar is 3 centimeter. Now there is a cloud, and in this cloud there will be water droplets. Airborne weather radar is used to detect large water droplets. Now when the size of water droplets is equal to the size or wavelength of the radio signal, there will be reflection. There will be reflection from this large water droplets. Now, if the size of the cloud or if the size of the water droplet is less than size of water droplets less than wavelength, what will happen? This radio signal will penetrate this cloud layer. It will penetrate this cloud layer, will go through this cloud layer and beyond it. So there won't be any reflection obtained from the large water droplets, because in this case the water droplets are smaller in size than the wavelength used. Say wavelength is 3 centimeter, maybe the size of water droplets is much less than 3 centimeter. Okay, so therefore the size of the water droplets and the wavelength that you are using, wavelength and frequency, are inversely related. So these two factors determine whether or not a cloud will be detected. Question 24. In order to ascertain whether a cloud return on an airborne weather radar is at or above the height of aircraft, the tilt control should be set to what angle? Assume a beam width of 5 degrees. So I have explained this before. I'll do it again. So this is your aircraft and this is the horizontal datum in front of your aircraft. Beam width of 2.5 degree, that means beam width of correction 5 degree means is a 2.5 degree above the horizontal and 2.5 degree below it. So this makes a total beam width of 5 degree. Now if you want to determine whether there is any cloud above your aircraft height, what you will do is you will deflect this radar beam upwards. You will tilt this radar beam upwards. Okay, and you will focus this radar beam at the cloud to determine its height. So the new diagram will look something like this. The same aircraft I am drawing here. Okay, the horizontal datum. Now this side of the radar beam will be deflected or will coincide with this horizontal datum. So something like this. 2.5 degree up and this another 2.5 degree. So this section of 2.5 degree is this and this part is this one. So basically you have deflected this beam up by 2.5 degrees. And now this total beam will be directed at the cloud, will be directed or focused on the cloud. So the correct answer will be 2.5 degree up. Okay. Next, question 25. In an airborne weather radar, the area of greatest turbulence is indicated on the screen by. So, in case if you are using a screen which employs colors, so in that case, the area of greatest turbulence will be indicated when colors change rapidly over a short distance, over a short or over a small distance, meaning the rainfall gradient is nothing but a change in something over a distance. Rainfall gradient or color gradient very steep. Just like meteorology lapse rate, we say lapse rate is steep. That means the fall in temperature over a certain distance is very huge. Or pressure gradient, temperature gradient, change in pressure over a particular distance is very steep, meaning the pressure is falling at a much rapid pace. So similarly here the color gradient is very steep, meaning the color changes from green to yellow to magenta to red color very fast over a short distance. So on the weather screen, this will be represented something like this. So let's say this is your weather screen. This is a red color zone. Then I'm drawing a yellow color zone somewhere here and then a green color zone here. So when you transition from green to yellow to red, you will encounter turbulence. Okay, just like fronts. Front is nothing but a boundary between two contrasting air masses. So when you cross that boundary, you expect wind shear, you expect turbulence. Similarly here, when you transition from green color zone, which is a safe area, to a yellow color zone, medium, to a red color zone, heavy, strong, severe zone, so you are going to expect turbulence. So wherever the color zones are much closer together, you are going to expect turbulence. Next, this is in case of color display. Okay, so color zones of red or magenta are no, color zones of green, yellow, no, areas which are colored black, no. The correct option is option bravo. Now, contrary to this colored display, there is another display called monochrome display. Called monochrome display. Okay, monochrome display is nothing but monochrome display is nothing but black and white display. In this case, the area of greatest turbulence will be represented by a white color dot. Now, white color cannot be represented, but this white color can be represented when it is surrounded by this black boundary. Now, this black boundary denotes the boundary of a cloud, and the white region depicts the area inside the cloud where you expect turbulence. Okay, so this is called monochrome display, black and white display, also iso-echo facility. All mean the same. So blank area where there is no color, meaning white color. So this is again another area of heavy turbulence. So remember this both types of displays. To improve the detection of precipitation in thunderstorm, in which the top of the cloud lies or slightly above the level of light. So the correct answer here is in order to detect a cloud which is above your flight level. That means let's say this is your aircraft and there is a cloud in front of you like this. Okay. Now to detect this cloud layer, the tilting should be lower when aircraft flies. Now let's say this cloud layer is in front of you and the cloud is much above your height, much above your altitude. In that case, the tilting will be directed upwards. The tilting of the radar beam will be directed upwards with respect to the horizontal. Okay, so directed upwards with respect to the horizontal. Now, when your aircraft climbs, now take the same cloud. Now, this aircraft climbs from lower altitude to a higher altitude. So, in that case, when it climbs to a higher altitude, radar beam will be deflected a little bit downwards. It will be deflected downwards. Because now aircraft has climbed to a higher altitude and now the cloud is at aircraft's height or below it. So now the tilt should be aimed downwards. So the correct answer is option A. The tilting should be lower when aircraft climbs to a higher altitude. Okay. Next. Question 27. Which statements relating to stabilization of airborne weather radar is true? They are stabilized with respect to pitch, roll and yaw axis. Wrong. Only pitch and roll, not the yaw axis. They are stabilized with respect to yaw axis. No. They are stabilized with respect to pitch and roll, but not with respect to yaw axis. Yes. Option C is right. The pilot can choose the axis of stabilization. With system stabilization, select a switch. That is wrong. Okay, it cannot be done by the pilot. Next, question 28. Airborne weather radar has been primarily developed to detect what? So it is primarily developed to detect areas of heavy turbulence. But you cannot detect turbulence directly. You can detect turbulence indirectly by detecting large water droplets directly. So first you detect large water droplets. Upon detecting them and representing that information on the screen in form of different colors, you can figure out where to expect or where to find areas of heavy turbulence. So areas of wind shear and severe aircraft icing, areas of clear air turbulence, the kinds of precipitation which are usually accompanied by turbulence, all kinds of frozen precipitation like hail, snow and graupel. So correct answer is most appropriate is Charlie. Now precipitation, all kinds of precipitation, frozen, okay, be it frozen or be it not frozen, and basically turbulence is the key word. Okay, we are detecting precipitation in order to detect turbulence. Okay, so that is the main purpose. Wind shear cannot be detected, clear air turbulence cannot be detected. Next, question 29. The antennae of modern airborne weather radar are stabilized by what? So we all know that antennae of airborne weather radar are stabilized pitch and roll axis, and this happens by help of with the help of aircraft's attitude and heading reference system, AHRS. So option B is the right answer. Very important question. Question 30. Heaviest turbulence is likely to be encountered where the area of heaviest precipitation is closest to the edge of thunderstorm cell. Option A is right. Okay, so you're going to encounter heavy turbulence at the edge of a thunderstorm cloud, around the boundary of a thunderstorm cloud. So remember this option A. This concludes our lecture. I hope you have understood all the 10 questions that I have solved, answered, explained in this video lecture. If you have any doubt understanding anything, or if you want to clarify any concept, let me know in the comment box. I'll definitely give a reply to your comment. I request you all to subscribe to this channel if you have not yet. Share this video with your student pilot friends, other pilots who are preparing for exams, and hit the like button if you have liked this video lecture. Thank you for your time. All the best. Don't miss my next lecture in which I will solve the next 10 questions. See you there.